In this video, we will show you the operation of the conductor selection module of Sizer Electric. We will describe the process to create a new project, define project specifications, enter information of a circuit, and select a conductor size. We will also review the conductor specification, and finally we will print different reports. To create a new file, we should select the option Project in the main menu and then New. A dialog box will appear. This is where we will define the project file information. We need to define the type of project we will create in the section on the left. There are three options: circuits, circuits with typical data, and also grounding grids. For a conductor project, we can select one of the first two options, circuits and circuits with typical data. The first option generates an empty file to start a brand new project. The second option creates a file with the project specifications commonly used in the industry. Let's select the option Circuits with Typical Data for tutorial purposes. Next, we will enter the name of the project file and select the directory where the information will be saved. Press the 3 points button. We can select a different drive and a different directory to allocate the project files. When completed, press the Create button. Next is References. After we have created the project file, the References window will appear. Here we must enter the project name, the customer name, project location, and the name that will define the documents and the reports printed by the software. Following, we enter the name of the person populating the information with an email and a phone number. After that, the information of the person that will be reviewing the project, and finally the information of the person that will approve the reports. To validate and save the information, press the OK button. If you want to edit the information of the References window later, you can select the option View in the main menu and then select References. Next is Standards. After you have entered the project information in the References window, the Standards window will appear. In this window, you can identify three tabs. In the Standards tab, you will define the code or standard that will be used for the project computation. You can select between the latest version of the National Electric Code or the Mexican official standard. Then you should select the frequency of the system. You can choose 50 or 60 Hz. Following that, you define what will be the maximum voltage drop allowed for the circuits during normal operation and during motor starting in the case of the circuit is feeding a motor. This information can be modified later at the circuit level for accurate results. In the Specification Frame tab, you can select the conductor specifications to be used by the software. You can choose between the standard Sizer Electric library based on average information of multiple vendors in the market, or the Southwire library based on specifications of this conductor manufacturer that corresponds to the specific products and references to increase the accuracy of your results. In the Conduit and Cable Trays tab, you will define what will be the maximum fill allowed for the conduits and trays. Although the standard defines a wide variety of cable trays, it is common in the projects that the cable trays and conduits are limited according to the customer requirements. In the next frame, you will define the minimum and maximum width to be used by the software to select the cable trays, and also the minimum and maximum conduit diameter to be used for the conduit. To select the cable tray width, the code allows you to have a common electrical conductor for all the circuits, or an equipment grounding conductor, also known as EGC, for each circuit. In this frame, you select the number of EGCs to be used to size the cable tray width. In the Additional Fields tab, you will find boxes to tag 3 user-defined fields for the circuit. These fields can be used to enter complementary information you may need to link the circuit with other databases or just add relevant information for your circuits, such as drawing name, plant location, and circuit status. You can also define this user-defined fields will be optional or mandatory by checking the corresponding checkboxes. Press the Accept button to close this window. Next is General Data. The next step is to define the project restrictions or project specifications defined in the software as general data. These are project requirements that will be defined for each load type and each voltage level. We can open this window by selecting the Views option on the main menu, followed by selecting General Data option, or you can select the General Data icon on the toolbar. This will show a grid with its own toolbar. This toolbar will manage the records in the grid. You can add, delete, edit, or filter the records in the grid. There are also different tabs defining load type. These records are restrictions or specifications to be used later for conductor selection based on the load and the voltage level defined in this section. Since this project was created with typical data, we can see some records preloaded with the common restrictions found in the industry. If you create a new project and selected the option Circuits, this grid would be empty and the information should be filled in. To edit an existing record, select the record by clicking with your mouse and then press the icon Edit in the grid toolbar. Or double-click on the record and this will show the primary window. A general data or project specification is defined per load and per voltage level. Here you can type the voltage level, define the phase number, conductor material, conductor insulation type, and the conductor operation temperature. To start the conductor selection, you will need the minimum and maximum conductor size allowed for the load on this voltage level. When the software reaches this conductor size in the iterative conductor selection process, and the conductor is not adequate, the software will select 2 conductors per phase and will continue with the conductor selection process until it finds a correct combination. The minimum and maximum power will validate that no load can be entered for the circuits out of this range. In the field Ambient Temperature, you will enter the maximum temperature surrounding the circuit. This temperature will be used later to select the temperature adjustment factor. The conductor type defines the overall conductor diameter, weight, and specification. The overall jacket describes the material of the external jacket used for multi-conductors and for the armored conductors. The metallic electrostatic shield is used for medium and high voltage conductors. In the single conductor color table, you can select the color for the conductors of each phase, the ground or neutral conductor, and for the equipment grounding conductor, also known as the EGC. For some systems, it may be required to define the color for secondary phases, such as in the deltas with central derivations. Click with the right button on your mouse for the contextual menu showing the color options. In the multi-conductor color table, you can define the color of the cables in the assembly, ground conductor, and the EGC. Select the OK button to validate the information and close this window. Next is Circuits. Having defined the standards and the general data of the project, it's time to enter the circuit information. To do this, select the option Views on the main menu and then Circuits, or simply press the conductor icon on the toolbar. This will show you the conduits grid and its own toolbar. In the grid, every record will contain the information of each circuit in the project, and each circuit may have totally different features and installation conditions. To enter a new circuit, we shall press the Add icon on the grid toolbar. This will show the primary window to populate the circuit information. This window is divided into 6 sections: General Circuit Information, the Circuit Data tab with the circuit electrical features and installation conditions, the Additional Data tab with the end user fields and colors, the Results tab where we will find the output from the selection process, the Specification tab where we will see the conduit's conductor definition and description, and finally the Technical Report where you will see the summary of the conductor selection process. Let's enter the circuit information. Type the circuit tag and press enter. Then type the tag MCC or switchgear that feeds the load. Provide a brief description of the load in the description field. Type the tag and the load and check or uncheck the box to define if the load is active or in standby. Enter the area where the load is located according to the layouts of the plant. Select the load type on the combo box. Please bear in mind that this combo box will only have loads you have previously entered in the General Data section. Bear in mind that some loads require specific additional information, such as motors and transformers. When selecting a motor, this will show a secondary window to complete the motor information, such as motor type, motor voltage, motor letter code, service factor, NEMA design, efficiency type, starting power factor, and duty cycle service to adjust the motor rated current for the conductor ampacity selection. Press the OK button to validate the information and close this window. You can edit the load information later by pressing the 3 points button next to the load type combo box. In this combo box, select the system voltage, number of phases, and the ambient temperature for the circuit. If you have noticed, this information links the circuit with the project specifications defined in the General Data section. You can see the General Data information associated with the circuit by pressing the 3 points button next to the combo box. Select the Circuit Data tab to enter the electrical load information and the installation conditions. The first field in this tab is electric power. Next, define the power of the load. Then, select the power units. Remember that the power should have a value within the minimum and maximum power range defined in the General Data section for this load at this voltage level defined. Sizer Electric includes a library for motors with typical efficiency and power factors. Due to this, when you change the motor power, the system will prompt a message informing that these values will be updated. Press the Yes button if you want to proceed with the update, or the No button if you want to keep the values or change those later. If you have the load nameplate current and you want to use this value, enter the value in amperes. This current will only be used for the conductor selection if the checkbox Final Information is checked. Otherwise, the application will calculate the load current. Therefore, leave the value in as 0. Next, enter the length of the circuit in meters. Next, define the number of wires in the circuit. Only take into consideration active conductors and neutral or grounded conductor. Equipment grounded conductor, or EGC, will be defined separately. Select the conductor type from the combo box. Next, enter the load power factor and the load efficiency. If the conductor is a feeder, enter the demand factor for the total load. For other loads, leave it in as a value of 1. Then select the installation media in the combo box. This will show you a secondary window to complete the installation conditions. In the case of a cable tray, you will need to define the cable tray type and the rung spacing in the cable tray. If a maintained space of at least 1 diameter of the largest conductor will be provided for the conductors, you should check this box. If the conductors will be installed one beside one another, keep it unchecked. If a cable tray is continuously covered for more than 1.8 meters, this checkbox should be checked. Leave it unchecked for uncovered cable trays. Please note that the adjustment factor field is not yet calculated. This is because the adjustment factor is defined during the iterative process for conductor selection. Once you have completed the process, you can return to this window and you will find the adjustment factor used. In the adjustment factor frame, additional information may be entered to adjust the conductor ampacity. In this field, you should define the percentage of harmonic content in your system to obtain the ampacity derating factor according to the recommendations of the standard IEEE 142. If your conductor includes a shield and if it is grounded in 1 or more points, you should assign the adjustment factor in this field. Lastly, according to the project requirements, it may be needed to define a specific adjustment factor according to the project specifications. For example, a security factor or a load growth factor. In the user-defined field, you can tag this adjustment factor and in the next field you can enter the value that should be used between 0 and 1. The product for all the cable adjustment factors will be shown in the total cable tray adjustment factor. If you have any doubt about the information to be entered in this window, press the F1 key on your keyboard. This will show you the help file with specific technical information about the code, as well as standard or recommended practice to fill in these fields in this window. In general, you can press the F1 key at any time to get help about the active window. Press the OK button to validate the information and close this window. Then select the field Material. Here you should define the material prevailing the installation. In case that the circuit is installed in more than one cable tray, raceway, or duct with different materials, select the material with the largest section of the cable tray or raceway. Next, select the maximum temperature of the connectors at the load side or the source side. Remember that this temperature will limit the maximum ampacity table for the circuit conductor selection. Then select the installation level. For low voltage circuit, you can only use 100%, but for medium voltage conductors, you can select 100%, 133%, and 173% installation level. In this field, you should define the maximum voltage drop. You may have noticed in the standards section, we have defined the maximum voltage drop, and that is the default value shown in this field. However, you can define what will be the maximum voltage drop for this specific circuit if it is a feeder or a branch circuit. Sizer Electric will select a conductor that does not exceed the voltage drop defined in this field. With this checkbox, the conductors will be selected to comply with the short circuit thermal stress. This verification is optional for low voltage circuits and mandatory for medium and high voltage circuits. Checking this box will show a secondary window where you should enter the short circuit current in kiloamperes, the fall time in cycles, and the maximum elevation temperature allowed for the conductor installation. The temperature shown by the default is obtained by the installation type defined in the general data section for this load and voltage level. The checkbox in this window is used for a special purpose. If the box is unchecked, the short circuit current is assumed as the current available at the load side of the circuit. If the box is checked, Sizer Electric will consider that the short circuit current is the only one available at the bus level and will compute the current decreased by the effect of the resistance and the reactance of the conductor under analysis. This way, the thermal stress verification will use the maximum current available at the load side that is really conducted by the circuit and not the short circuit current available at the bus level. That may oversize the conductor. Press the OK button to validate the data and close this window. This box should be checked to select the equipment grounded conductor. This will open a secondary window where we need to select the protective device type for the circuit. Once we define the protection type, the application will suggest frame and setting, or fuse holder and fuse capacity, according to the power defined for the load. These two values can be modified to describe the real protective device values obtained from your protective device coordination study. We should remember that Sizer Electric will select the equipment grounded conductor size corresponding to the protective device and will increase in size proportionally according to the increase in the area suffered by the underground conductors. Press the OK button to validate the data and close this window. If the conductor has electrostatic metallic shield, you can calculate the induced voltages on it and the grounding distance to keep the induced voltage at a safe level, according to the recommendations of the standard IEEE 525. To do this, select the checkbox called Shield Grounding. This will show a secondary window with 4 fields. In the first combo box, select the installation detail for the conductor's layout. Then enter the distance between the center of the conductors. In this combo box, select the shield type and later type the maximum voltage allowed for the shield. This information will be used to compute the maximum grounding distance to prevent the shield-induced voltage exceeding this safe voltage value. Press the OK button to validate the data and close this window. As indicated before, the final information checkbox will define if the value entered in the nameplate current will be used for the conductor selection. Leave it unchecked if you want the software to calculate the current following the code requirements. Next, select the Additional Data tab, where you will find 3 user-defined fields to enter information you may need to complement the circuit information. As described in the Standards section, the name of these fields can be customized, and you can make them mandatory or optional. To make the process easier, once you type the data in these fields, the information is added to the list to select this information for other circuits later. The Circuit Conductor Color table shows the default colors you have defined in the General Data section. You can change the colors in this section and make this current different from other circuits. Lastly, in the Observations field, you can enter the complementary information as needed. When we have completed all the fields, we are ready to select the conductor size. Press the Calculate button. When Sizer Electric completes the conductor selection process, it automatically activates the Results tab, where you can find the conductor selected per the ampacity, voltage drop during motor starting, and short circuit. This section will show you the suggested conductor size. If you need to select a different conductor size, click the Change Size to checkbox. Then in the combo box, select the required size, type of conductor per phase, and press the Calculate button at the bottom of the window. Sizer Electric will validate if the conductor selected complies with the requirements of the code. The Errors and Warnings section shows deviations found in the conductor selection process. In the Specification tab, you will find a grid with specification created for the circuit conductors. In the first column indicates if the specification was found in the library. The green color indicates the conductor was found, and the red color indicates that it was not found. The conductor column defines a specific conductor, whether it is a phase A, B, or C, grounded, or EGC. Following, you can find the 10-position monotactic chain to link the conductor with the Conductor Specification library. The Info column shows a button with a question mark. By pressing this button, a secondary window will appear showing a comprehensive description of the conductor, including the weight, diameter, and the alias or label assigned to this conductor in the specification library. At the bottom, you can find a very useful link that will take you to a conductor technical data sheet available on the web to verify the conductor features. Press the OK button to close this secondary window. In the User column, you will find a checkbox. Clicking on it enables a 3-point button in the Change column next to it. By pressing this button, a secondary window will appear where you can associate a different specification to your conductor by highlighting the new specification on the list. The fields in the upper part of this window helps you define the filter criteria, and the Filter button executes the selection. The OK button completes this user specification selection. Finally, the Technical Report tab. The Technical Report tab shows the final technical details for the criteria used during the selection conductor process. It includes ampacities, derating factors, and results from the computation. Use the scroll bar to go through the details. Press the OK button to save the circuit information. The window will be closed and you will see that the conductor was added as a new record in the grid. To see a comprehensive report of your circuit, highlight the circuit and press the Calculation Sheet button on the grid toolbar. Here you will see the circuit data, references, code articles, and the formulas used for the conductor selection. The Report toolbar will help you to navigate through the report, change the size, and print it. You can also print the tabular report for all the circuits in the project by selecting the option Report in the main menu and then selecting the option Circuits. This will show you the different reports available for the circuits. Select the report required. A window will appear showing filtering fields and the heading to customize a report. Define your filter criteria and press the OK button to show the circuit tabular report. These are the basic steps to manage the conductor selection module. For detailed information, read the software manual or visit the help files included in the software and the option for help on the main menu. Thank you for your attention, and we recommend that you see complimentary videos for conduit and cable tray sizing and ground and grid design for a complete knowledge of Sizer Electric software.